Hi everyone, this is our tutorial on how to develop a multiple regression model. So to start off with, I am going to run a correlation to get some background on the statistics I will be using in my model. You've already done this as a part of your individual homework assignments, but just in case you want to double check your values, you can go to Analyze, Correlate, and click on Bivariate Correlations and add the following variables into your correlation matrix. So in my case, my dependent variable is if someone has carried a weapon in the last 30 days, and my 4 independent variables that I will be assessing are electronic bullying, smoking, riding with a drinking driver, and body mass index. So for options, you will click on Exclude Cases Pairwise, Flag Significant Correlations, and Pearsons, and we will hit OK. So this will provide me with a correlation matrix in which I can double check how each of my independent variables here correlates with my dependent variable here. So the first thing I want to do is look at the value of my correlation coefficients, and I specifically want to look at the size. So remember, the size has nothing to do with the sign. So if, for example, my sign is negative, but my actual value is larger than a positive number, then that correlation is a stronger correlation, even though it's inverse. So we will look at the largest based on size regardless of sign. So in my case, 0.249 is the largest, followed by 0.166, followed by 0.043, followed by 0.029. So in terms of building my model, I will start with smoking. My second variable I will test will be riding with a drinking driver, then body mass index, and finally electronic bullying. So to start with my regression modeling, I'm going to go to Analyze Regression, and I will go to Linear. So that's Analyze Regression Linear. And I'm going to start with only my first variable, which was the largest size effect of a correlation of smoking on my dependent variable of carried a weapon in the past 30 days. For statistics, I will click on Estimates, Confidence Interval at 95%, Model Fit, R-squared change, and Descriptives, and Durbin-Watson, and hit Continue. For plots, if I was testing assumptions, I would have some values here, but since I'm not testing assumptions right now, I'm just going to hit Continue. Finally, again, under Save, if I was testing some assumptions, I would click some of these on, but since I'm not doing that, I will hit Continue. For options, I want to be sure to have Include Constant in the equation clicked on and Exclude Cases listwise. So be sure your method is set to Enter, and you will hit OK. So here, what I can see is my adjusted R-squared in my model summary is 0.062. This means that my predictive model is 6.2% better than just using the mean as a predictor. When I look at my Durbin-Watson statistic, it's close to 2, which means that it's a fairly good fit model, and you can read more about this on the Laird's website. The ANOVA will test the significance of my model itself, which in this case is 0.000, which is less than 0.05, which means this model is statistically significant. And here, these show me the values of the coefficients if I were to create an equation for my model. So the first next to constant is the intercept under beta, and then the coefficient for the smoking variable is 0.212. The standard error for each of the variables shown here, and the significance for each of the variables is shown here. Then the lower bound of the 95% confidence interval and the upper bound of the 95% confidence interval are both shown in this table. So using just one variable of smoking, I've already improved the predicted value by 6% over using the mean. Next, I'm going to go to Analyze Regression, Linear, and I'm going to add in my second highest coefficient. So in this case, my second highest was riding with the drinking driver, which is question 10. So I have two variables, smoking and riding with the drinking driver, and they should be in this order because the order does matter. And my dependent variable is carried a weapon for 30 days. All of the remaining test assumptions I leave the same, and I hit OK. Now I check my results. In my new model, my adjusted R-squared is 0.072, which is higher than in my first model of 0.062, so it appears that this variable has added something into our model overall. I check my Durbin-Watson statistic. It's still close to 2, which is good. And then my ANOVA shows that this value of significance for this two-variable model is statistically significant at 0.000, which is less than 0.05. Finally, if I were to develop an equation for this model, I would use the intercept, which is equal to the constant value here, and then for my first variable, I would use the coefficient of 0.193, and my second variable, the coefficient of 0.124. I check the significance of both of my variables, and they are both statistically significant. So that indicates that this model, I am going to keep both variables. Now I'm going to go back again and run it a third time. So I'm going to go to Analyze Regression, Linear, and here I'm going to add in my third largest variable based on correlation, and that was electronic bullying. I'm sorry, that was body mass index. So body mass index, I go ahead and add into my model as my third variable. I leave all my assumptions the same and I hit OK. Now I check my model's R-squared value. As you can see, the R-squared value has actually reduced from 0.072 with the two-variable model down to 0.062 for the three-variable model. Durbin-Watson is still good, close to 2. The significance of the model with the three variables is statistically significant, less than 0.05. And if I were to create an equation for this model, I would use 0.967 as the intercept, and then each of these values here as the coefficients of the equation. Here, each variable does have statistical significance. However, because my overall R-squared value reduces by adding body mass index, I'm going to delete body mass index from my model equation. So then I'm going to run this a fourth time. So I'm going to remove body mass index, and I'm going to add in electronic bullying, which is my last independent variable. I leave all my other assumptions the same, and I hit OK. Now, in the fourth run of my model, I can see that the adjusted R-squared has raised again to 0.071. However, this is still less than 0.072, which was from my second version of the model. Durbin-Watson is still close to 2, which is good. Significance for the model itself is significant because it's less than 0.05. And the coefficients for this model are listed here. And as we can see, the new coefficient of electronic bullying is not statistically significant with a p-value of 0.574. So, because of the two reasons that my overall R-squared value of 0.071 is not better, and the significance of this particular coefficient is not significant, I am going to remove the electronic bullying from my analysis. So in my final version of the model, I'm actually going to only have the first two variables, and I leave all of my other assumptions the same. I hit OK. And in my final version of the model, I have what matches the second run I did, which is an adjusted R-squared value of 0.072, the Derwin-Watson statistic fairly close to 2, a statistically significant result for the model itself under the ANOVA table of 0.000, and then these would be the actual coefficients that I would use for the equation for my final model. So in this case, my intercept would be 1.007 plus 0.193 x sub 1 plus 0.124 x sub 2. And that would be my final result. Good luck, everyone.